Hi, I'm Jason with Lily White Water Solutions. I'm going to show you this program that I've developed. It is called Integrated Agricultural and Municipal Demand and Delivery Model. I call it IAMDD. So what is this big long named model all about? Well, it's an integration of hydraulic modeling and comprehensive agricultural water demand and municipal water demands that drive the hydraulic model. So those three things are all tied together in this, all in a web interface. So how do you get to this model? Go to my website, go under Products, IAMDD, and then you'll have to log in, and then click on Open Your Dashboard or a new blank model. So I'm going to start with an existing model that I've built. This is a test model I built with a hypothetical water system, but in a real location. I had to do this because I'm testing scaling large models that have to run on a cloud server. Okay, so if you zoom in, you'll see there's lots of areas: green, purple, blue. These all represent different types of land use. And then there's also all these dots and lines. Those are for the EPANET model that's running underneath. And so essentially what you do is you just start building the model. You use an aerial photograph to trace around things. I turned that off because this is a hypothetical model, like I said, but you can create different shapes of things. You can create rectangles, and as soon as you create one, it picks up, it defaults to agricultural land. That's green, and then it collects the soil properties underneath that area and puts that into the input field here. And then you can specify other inputs like crop types, which are automatically populated into the model for your location. These are based on USDA information. Same thing with irrigation methods in this area, and the area is computed. So you can also change this to municipal, and then you see the color changes, and then you can put in a number of units, and you can also pick those up from GIS, and you can change it to different densities. You can change it to commercial. If you change it to commercial, it goes blue, and industrial goes to brown. And all of these are associated with components in the library. So if you go up to the library up here, we have we have different densities that you can define. So there's a list here already, but you can add more. They all have parameters associated with them. So like high density residential, you can check a box for multifamily. Then there are other types of you can do polygons. I won't go through and draw them all, but you can do circles, for a center pivot irrigation, and then you can draw nodes and links. So here's a node, a couple of nodes here, and then you can connect them with a pipe. And then once it's connected, then you have the chance to change the pipe to either a pump. If you change it to a pump, then you can define the pump there. You can change it to a valve. And you can also change a node to be either a reservoir or a tank or a flow boundary if you want to just define a flow coming in or out with a time series, for example. All of these components are similar to what you have in EPANET, just drawn in on the browser. So I'm just gonna delete these here. Okay, so that's how you draw the map. And now I'm going to talk about the parameters that we can assign to this. Oh yeah, and you can expand the window there. Okay, so let's just zoom in a bit here, and then I'll turn on the map layer. Okay, so here we can see based on the map. Right now, this is a residential area, and then here's commercial, here's industrial, and you can see that there's a pipe node. this pipe coming down the road here. There's a pipe node inside of the area. If you put a node in within a boundary of an area, then it associates it and attaches it to that land. The reason I do this is so that the demand that we calculate for this area becomes a driver into the hydraulic model. So the model tries to deliver that demand. So you'll see that that's why we have these connections here to the pipe itself. On the agricultural side of things, if you go up here to the library, you can go to crops and define the crop and look at how the KC value changes over the growing period. I use growing degree days, by the way, not just static calendar. And then up here in the library again, you can define patterns for the different types of land use that you have, and you can dynamically adjust these patterns here, and you can add your own. And then let's see. Oh yeah, this one's kind of cool. This one is for rotation scheduling for irrigation. So this is common in agriculture and irrigation districts. So you can adjust this this bar right here, which is essentially the time that the lateral is turned on, and then you can kind of line them up and stagger them so you have different schedules, and you can create as many as you want of these. You can adjust the interval to make it, you know, a longer period. You can make it a 2-week interval instead of a 1-week interval, and make all these adjustments. Anyway, once you do that, then you can assign that to a pipe. So you can click on a pipe. Imagine you have a lateral that goes to many irrigation fields or agricultural fields. Then you can assign that particular pipe to that schedule, and so that could affect multiple fields. And then what that does is when it's off schedule, it just shuts that pipe off. So it's a really easy way to schedule those. And I'll do another video about how the model does automatic staggering and scheduling and ensuring that well, what it does essentially, just real briefly, the model will control, it will calculate flows to the irrigated area based on the pressure that's there, and also its soil water depth. Okay, so that's basically how those are all set up. There's a few other things we could go through, but I'm just going to go ahead and run it. So let me turn the map off, zoom back out, and let me just go ahead and do a run now. So I'll just and the time settings here. Really, this model is just intended to run for either just a forecast period, let's say for the weather forecast period of 14 days going forward, but you could also run it for the entire irrigation season or an entire year. That's really what it's meant for, but it always runs on an hourly time step basis. So you can adjust start and end dates based on that within those constraints. So this is going to run for 15 days. So I'll go ahead and click run here. So this is running on a dedicated server for this purpose of running simulations, not on the same server that my website is on, but a dedicated server that will enable concurrency. So you could have more than one person running on this at the same time. Although currently, just because this is just starting out, I've got you know, just to save money, I've got a cheaper server. So it's this could have run faster on a more powerful server. It turns out slightly slower than my laptop, but like I said, this could definitely be scaled up very quickly, very easily, for a little bit more of a cost on the server side. And okay, so now that this has run, now we have color coding for pipe velocities. This represents the maximum velocity that was reached during the simulation. That's what these colors are for, and you can see them here in the settings. And you go to visualization settings, you can see these are the colors associated for the nodes and the pipes. Then you can also click on any of these areas, and you can double click here and zoom in to get an idea of what the outdoor and indoor water usage is. You can tell right now that this model is set up to not allow daytime municipal or residential irrigation. That can be set up here in the residential setting right here with this checkbox. For some dry areas, that's can be a requirement. For agricultural lands, you can zoom in on that and see that this shows the wilting point in red and the field capacity up here. And so we turn the irrigation on to get back up toward field capacity, and then it shuts off. If there's not enough pressure in the node that services that land, then we won't be able to meet the demand. So you can see that there's some red areas. Any place that's red means that we didn't meet the demands at some point during the simulation. So that's this area right here, and it could be because of low pressure. And in addition to looking at results for individual areas, we can go to look at global results. This shows climate, evapotranspiration, the average soil water balance, and then also total supplies. We can look at final value supplies. These are cumulative over the period of the time that was simulated. And this is just one scenario. So multiple scenarios, you'd have multiple stack bars here, but it shows all the different types of crops and the amount of power used, or the amount of cost for the power used for pumping is here, and total supply for the different types of land uses. So there's a lot of results that you can see here, but as you can see from this, it's an integrated approach to looking at both the combination of the demands and how water is being delivered to those demands. So I'm really excited about this model. I think it's really fun to use, and I hope that you get a chance to check it out on my website. So thanks for watching.